Ah, okay. Thank you very much, Buddha. So, yes, there is management. Uh, so, thank you, Seb Online lectures. So, that's from the management. Thank you very much for starting the recording. Okay, so again, for the records, Buddha, good evening to all of you. Very glad to see you all. And now the recording is on, so we can now, without any issue, we can continue. So, let me again share the screen. Okay. So today we are discussing about t-test and one-way ANOVA, right? Of course, we started discussing and we are halfway through. And we were discussing what? Test of differences. Difference between two groups. Now, when we are going to perform test of differences, we can perform difference between two groups, right? If you are going to compare two groups, Buddha, we are performing what? Someone answer. If you are going to compare two groups, taking some character like satisfaction, stress, or whatever, and if you want to compare two groups, what the test we do?
Independence.
Independent sample t-test or the t-test. Two groups, you can see on the screen it says, if you want to compare two groups, you could perform t-test. And if you are comparing two independent groups, you could perform what? Independent sample t-test. On the other hand, if some two characteristics are paired by a person or a company, then you are going to compare those two characteristics based on what? A paired sample t-test, right? A paired sample t-test. So we discussed about independent sample t-test, where we were comparing two independent groups. So here we took the example where we compared between experimental group and the control group. Experimental group was the group that was given the training, and control group was given no training and kept as control. Right, please hold on. So please go through the notes. Give me about 2-3 minutes. Okay, students, sorry about that. There was a sudden call from home, right? So I had to take it. Critical calls come, what to do, no? Right. No, I think you now reminded yourself. So in an independent sample t-test, what we do is we compare two groups, the experiment or the treatment group with the control group, two independent groups, right? And then what we did was we followed how many steps in doing this comparison. How many steps are followed?
4 steps.
4 steps. Very good.
4
Excellent.
steps.
4 steps. Excellent. How about others? I got 2 answers from 2 good students. How about others? We followed 3 steps, no? You can see on the screen we have 3 steps. Not 4 steps, no? Do you agree? 3 or 4?
4 steps.
Steps.
4 steps, indeed.
Conclusion also is good.
Yeah, very good. Right. Yes, you can see the next step is here. Step number 4. Always, Buddha, we were following 4 steps, isn't it? So we started with hypothesis, developing the null hypothesis, establishing the null hypothesis, establishing the decision criteria. Then using data, we perform the required test. It might be independent sample t-test, it might be a paired sample t-test, or it might be even the one sample t-test. And based on the result, we came into the conclusion. That they also, right, I told you, whether it comes from the same population or not also could be decided based on the significance value of the p-value. And so we discussed these things. Good, very good. So students could remember that very well. Huh? Appreciate it. And then also we did the testing for both the life satisfaction as an additional exercise as well as another additional exercise on perceived stress. Always we followed how many steps? 4 steps. Right. Then we came into the paired sample t-test, where we call it the dependent sample t-test. Also, we call it the dependent sample t-test, paired sample t-test. Here we understood the information is paired. Now, for an example, see, here we have 7 salesmen. Now, the same salesperson has done mathematics as well as English test. Right, mathematics and English test results. And math test and English test, you can see the same employee has done. So we can see it's paired. So that's what we call it, a paired sample t-test. A paired sample t-test. So, and the information, the 2 information, math test results as well as English test results are paired by, right, each employee. So in that case, it's wrong to do an independent sample t-test because there are no 2 independent groups. We have pairs, right? We have pairs here. In that case, we do paired sample. It's paired. So we do a paired sample t-test. Then again, how many steps we follow? Always 4 steps, right? Always it will be 4 steps, not 3 steps, 4 steps. So again, establish the null hypothesis. Again, establish decision criteria. Then using data now, perform a paired sample t-test. And then come to a conclusion. And again, we did on moods, positive and negative moods, we did the survey for ED. We took the usual file and we did the testing. And today what we need to do is we have to perform the one sample t-test under the t-test. I told you that under t-test, how many tests are there? T-test test how many tests are there? I'm going again to the beginning. Yeah. Under t-test, you can see the independent sample t-test, paired sample t-test, and you have the what? One sample t-test. Clear? Now today, that's what we are going to discuss. So let's go back. Let's go back. So we are quickly going through what we did. And here we have got the one sample t-test. What it does, right? What it does is, right, under paired sample t-test, what it does is, it compares the average value, the mean value of a sample with a given value. With a given value. Let me take an example. Let's say, Puta, you have 2000 bulbs that you have in, let's say you are working, you are a manager, you are the accountant, right, for a bulb manufacturing company, and they have manufactured 2000 bulbs, right? And let's say this particular bulb should last for 1000 hours, at least 1000 hours. That's the benchmark. Let's say the quality standards require that this bulb to last, right, at least 1000 hours. The lifetime should be 1000 hours at least. So that's the average burning time. That's the average burning time, 1000 hours. We hope that it will be there at least for 1000 hours. Right? At least for 1000 hours. Okay. Now, let's say they have manufactured in the organization that you are working as an accountant 2000 bulbs. Now you want to see whether these bulbs have an average lifetime, or at least a lifetime, or not average lifetime, at least the lifetime of 1000 hours. So what can you do? Well, what you can do is you can take the 2000 bulbs, light them, and see whether it would last for 1000, isn't it? Do you agree? Hmm? You want to check whether it would last for the 2000 or 1000 hours. So you light the 2000 bulbs and you see whether it would last for 1000 hours. Is that correct? If you agreed with that, then after that, what these people are going to sell? If you light all 2000 bulbs, what can you sell after that? So if you agreed with that, and if you are the accountant of that organization, I don't think that organization would last for long. Okay. If I were you, I would be doing a different thing. Right? If I were you, I'll be doing a different thing. What's that? What I'll do is, out of these 2000 bulbs, I'll take a sample. I'll take a sample and I will light only that sample. Let's say, Bhutan, I took the sample of 10 bulbs and then I light them. Then I light those 10 bulbs on. And you can see here on your left-hand side, in fact, in your right-hand side, right, you have the bulb lighting times for these 10 bulbs. 800 hours, 750, 940, likewise, the burning time is there, right? So the burning time here is that. So the first bulb lasted 800 hours, so second one 750, likewise. Then now what we need to do is, this is a sample, and what we expect is 1000 hours. So what you can do is, you can take the sample mean. I have calculated that already. Let's say the sample mean is 867 hours, for an example, right? If you take these all bulbs, I have calculated already. Let's say I have taken the total of these burning time and divided by 10, then came 867 hours, right? 867 hours. Let's say the burning time is 867 hours on average time. Then what I'm going to do is, I'm going to perform a one sample t-test and see whether this 867, now the sample comes from a population where the burning time is 1000 hours or not. For that, I'm going to perform a test called one sample t-test. In a one sample t-test, what you do is you take the average burning time of the sample here in this case for these 10 bulbs, 867, and you are going to compare that with 1000, the benchmark. And you are going to see whether there's a statistically significant difference between 867 and 1000, right? And if there is a statistical significance, then you will say, no, these bulbs cannot come from a population where the burning time is 1000 hours. Because 867 in that case seems significantly lower than the 1000 burning time, right? The benchmark. So that's what we are going to look at using the one sample t-test. Let's do it together and you'll see that much more clear. Right? Again, what we need to see is, again, just a scenario. The scenario is that, let's say you have 2000 bulbs that you have manufactured. You need to establish whether the average burning time of these bulbs are at least 1000 hours. So what you did was, you took 10 bulbs and then you lit them, right? Then you lit them for till it lasts. And you saw that these bulbs last 800 hours, 750, 940, likewise. These 10 bulbs lasted this time, right? Average lit time. Okay. So let's see how to perform this one sample t-test. Again, as I told you, you are going to perform the 4 steps. Always these 4 steps will be performed, even in the next, right, one-way ANOVA test, where you are going to compare more than 2 groups, right? There also you'll be performing these 4 steps. So what's the null hypothesis in this case? You can see the null hypothesis H naught colon. There is no statistical significant difference between the average mean burning time of the sample of bulbs and 1000 hours. Population mean. Population means is your expected mean. So sample mean burning time, and there's no significant difference, and 1000 hours. So you can see that's the null hypothesis. No difference between the average burning time of the sample and 1000 hours. Here 1000 hours is considered to be the expected population mean of burning hours, the benchmark, right? So again, the same null hypothesis that we established, saying that there's no difference, right? Then you'll be going for the decision criteria. Decision criteria is again exactly the same. If the sig value or the p value is less than 0.05, reject the null hypothesis. That had been always the what? It had been always the decision criteria, right? Always it was the decision criteria. Then what you can do is, using stata, perform what? Perform the one sample t-test. Okay, so that's what I'm going to show you now, right? Just go out of this and let's see now how to perform a one sample t-test using stata. But before that, you need to download the data file and then open that in stata and perform the one sample t-test, right? So let's see how to do that. So to do that, first of all, go to your LMS and download that data file. You can see seems that file is not there. So let's insert that file. Okay, let me put that file, which that file is not there. Employee training, without training, it was there. So this is the employee mathematics, caffeine and productivity is there. That file has not come. So let me put that file so you can download it. So go to week 7 and see that, right? I'm going to put that now. So you can see light bulb, data session 5 light bulb. First of all, let me on the editing and go to week 7 and still it's not there. Let me put that for you. Yeah, under this I put it light bulb. Right, so you'll see that there's a file called status session 5 light bulb. So if you cannot see that, please refresh the screen. Right, refresh this website and then you'll be able to download it. So please download status session 5 light bulb. Is it available, Puta? And could you download it? Is it available? Can you please confirm?
Yes, sir.
Very good, very good. Excellent. So then what you can do is you can open in Stata, right? So I'm going to open that in Stata. First of all, I'll fire up Stata. So I'm going to open Stata. Okay, Stata is there. I'm going to take Stata 19B. Then using this, maybe it's in your download folder. You can download it from here, right? So I'm not going to update anything. So I'm going to go to File, Open, and I'm going to go to my location, light bulb. Right. So in your case, it might be in the download folder. In my case, I'm going to go over here. I'm going to go to status session 5. I'm going to go for light bulb. Yeah, session 5 light bulb. .dt. I'm going to open that. And once you import, so that not import, once you open the file, better to view the contents of that file. How to view that? You'll go here and type what? Browse. Hit enter. Then it opens. You can see here. Right, you can see clearly. Let me use the magnifier as well, in case if you cannot see that properly. Here, you can see it's there. You can see it's opened. So I'm going to again make it to the original size. So you can see these are the 10 bulbs that are tested. Is that clear? So once you do that, you can then close the data editor window and come back to state. Now we are going to perform step number 3. Right? Under step number 3, what you are doing? We are going to perform the paired sample t-test. Or what? The one sample t-test. But you can see step number 3, perform the one sample t-test. So because we are doing the one sample t-test, we are trying to see whether the average of these 10 bulbs is significantly different from 1000 average, right? 1000 hours. To do that, so let's now, you can take down how to perform a paired in one sample t-test, not a paired one or independent. You are going to say you are going to perform one sample t-test. How to do that? Again, same way. You go to statistics, summaries, tables, and tests. Then what? Classical. Classical test. Right? Classical test. Then go to t-test, mean conversion. Then now you can see it says what? One sample t-test by default. Can you see that, Putai? One sample t-test. So if I use the magnifier, here, you have one sample t-test in the dialog. And you can see here one sample t-test. And you can see variable name you can select and the hypothesized mean. The variable name is what? Life. Life. Life is the burning time of those 10 bulbs. And what's the hypothesized value? 1000. Right? It's 1000. So these things only you have to fill. You have to just keep the default one sample and then go to variable name life and hypothesized mean 1000. Is that clear? And then press OK. Then comes the one sample t-test. Again, I'm going to increase the size. So look here, when you get the one sample t-test, it says what? Look at this table. It says the mean value is how much? Sorry. The mean value is 867. 867 hours. The mean value is 867. Now what we need to know is whether this 867 is significantly different from 1000. Any person could say it's different than 1000, it's lower than 1000, but this is significantly different. We don't know. So that's where we perform a one sample t-test. You can go down and yes, here you can see the one sample t-test is there. You can see the sig value, the significance value of the p-value is 0.0019. Right? So record that under step number 3. Right? Record that under step number 3. Is that clear for them? So that's what we have done here. So I have gone here and I have recorded it as 0.0019. Now my question to you, under step number 4, to conclude, we need to see whether this value 0.0019 is less than 0.05. Is this value less than 0.05? Yes or no?
Yes.
Yes, indeed. It's well below 0.01, 0.05. 0.0019 is well below 0.05. So you conclude what? You conclude that it is less than 0.05. So therefore you come into the conclusion. So you reject the null hypothesis, right? Since it's less than 0.05, you reject the null hypothesis, but okay, you reject that these bulbs come from a population where the average lifetime is 1000 hours. That's what you reject. The difference between our sample mean 867 and the mean of the population 1000 is so different, right? That it's unlikely that our sample would have been drawn from a population with the average life of 1000 hours. So it shows that this sample cannot come from a population where the burning time is 1000 hours. So what's your conclusion related to the 2000 bulbs? By your sample test, what you can say is that these 2000 bulbs are substandard, not good quality. Because our sample testing indicated that these 10 bulbs never could have come from a population where the burning time is 1000 hours. Why? Because 867 hours is significantly lesser than 1000 hours. So your final conclusion is that this lot that you manufactured, your organization manufactured, is not good quality. So that's what you tell finally. The bulbs manufactured are substandard, not good quality. This is Putha, how you perform, right? Quality testing. You take a sample, right? And you calculate the whatever the values of that. And then what you do is you compare that with the one, you perform one sample t-test and compare with the benchmark. And so if there's significant difference, lower or higher than the benchmark, then you will say that has some issue. In this case, it was lower. 867 sample mean is significantly lower than the expected 1000. So in that case, we'll have to conclude that these bulbs are of cheap quality. Right? Is that clear? So that's how you would perform a one sample t-test. Okay. That's how you would perform a one sample t-test. Any questions, concerns? Is it clear? Right. So let's now do a small exercise. Let's say you are going to measure life satisfaction. Okay. Life satisfaction. All right. Okay. It's in this slide. Right. Life satisfaction. In the 30th slide, you can see the life satisfaction measured. So you can see the highest value is 35. The lowest value is 5. Let's say, for an example, the neutral value is 20. Let's say life satisfaction is measured in a 5 to 35 Likert scale. You will understand later why it's 5 to 35, but for the time being, just understand the lowest value is 5 and the highest value is 35. Okay? So I want to know, right, in a Likert scale 5 to 35, I have measured life satisfaction. So I want to know whether the life satisfaction, right, the average life satisfaction. Now using survey for ED, session 3 survey for ED, right, this particular file, I want to know whether the average life satisfaction, is significantly different from the neutral value, 20. Right? What I want to know whether the life satisfaction is significant, average life satisfaction of these 436 employees is significantly different from 20. Right? So how to do that? Again, follow the 4 steps. Right? So step number 1, you can see clearly step number 1 says what? Establish the null hypothesis. Null hypothesis H naught. So let me also put H naught, colon, and this naught should be ideally a superscript. So I'm going to make it subscript, not superscript, subscript. Right? So H naught. So you would say this what? You would say the null hypothesis, there is no significant difference between the average life satisfaction of employees and the expected neutral value of 20. So that's how you would establish the null hypothesis. Right? What you say is the average life satisfaction, right, of these 436 employees, I don't know what's that amount. Whatever that amount is significantly different from 20. Why 20? Because it's the neutral value. Then establish the decision criteria. Again, same thing. If the p-value, probability value, or the significance value, which is sig value, is less than 0.05, reject the null hypothesis, which you always did. Right? Then what you can do? Now what you can do is open the dataset, right? Session 3 survey for ED file and do the one sample t-test and see what's the sig value. Shall we do that? Okay. So let's go to the LMS and locate session 3 survey for ED file. So it was here somewhere. If session 4, same thing, survey for ED. Here. In week 5, under week 5, you can see it's there. Status session 3, survey for ED. So I'm going to download that. Right. And I'm going to open that in Stata. To do that, I'm going to close the existing file, Stata file. You can even keep it open, there's no problem. And I'm going to open a fresh Stata session. Right, Stata 19B. And then I'm going to go to File, Open. And I'm going to go to my download folder. And here, there's that session. This is session 3, survey for ED. Please open it. And best practice is to view that file once you open that file. So I'm going to go to Browse. Browse. Okay, this is there. Good. I'm going to close this. Good. So it's open. So now I'm going to perform the one sample t-test. Statistics, summaries, then classical tests, t-test. Yes, one sample t-test. So let me use the magnifier. So here the magnifier, I got it. Now you are one sample t-test. Then the variable name is life satisfaction. So I'm going to go here. I'm going to go down, 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 down. Okay, and go lift it up. You can see there is T life set. T life set is the total life satisfaction, or you can just type this T life set. And what's the hypothesis mean? Benchmark value? 20. The neutral value, right, is 20. That's the hypothesis value. You say 20, and you are going to press OK. Okay. What's the average value of total life satisfaction? Total life satisfaction, you can see in the given output, the mean value is 22.37. Let's call it 22. So now the problem is, if whether this 22, the average value for life satisfaction, is different from 20. Whether there's significantly different from 20. Right? That's what you want to know. So you don't know whether 22 is significantly different from 20, you don't know. So that's why you perform what? A one sample t-test. So here it shows in the middle, the t value is what? The sig value, the p value or the sig value is what? 0.00000. Right? So that's the answer for step number 3. 0.0000. Right? So you record that. It's okay. And you go and record that over here. Using Stata perform one sample t-test and the sig value is 0.00. Now you compare this value with the step number 2 threshold 0.05. Question is, whether 0.0000 is less than 0.05? Is it less than 0.05?
Yes.
Yes. 0.0000 is less than 0.05. In that case, can you reject the null hypothesis? Can you reject the null hypothesis?
Yes.
Yes. Yes, indeed. Because 0.0000 is less than 0.05. So you can reject the null hypothesis under decision criteria, under step number 2. So what's your conclusion? Your conclusion is the average value 22 is significantly different from the neutral value of 20. On the other hand, you can say the employees are significantly satisfied with their life, right, than the neutral value. Good thing, isn't it? So that's what we have seen here. So I have given the conclusion. Since the estimated p-value or the sig value is less than 0.05, the null hypothesis that there is no difference between the average value of the life satisfaction of employees and the neutral value of 20 is rejected. So these employees come from a population where the average life satisfaction is well above the neutral value of 20. So significantly above 20. So that's your conclusion. Right? Is that clear? So this is how you perform a one sample t-test. This is how you would perform a one sample t-test. Right? Now let me give an additional exercise to you. Can you tell me whether the stress value is different from the stress variable? Whether the stress variable, now you have the PS stress, right? Perceived stress, right? TP stress, you call that variable TP stress. TP stress, whether it's significantly different from 20? Can you check that? I'm going to give you 5 minutes, right? So let me include that as well here as an additional exercise. It's exercise. Exercise. Good to do exercises. Right? You can say examine the, the total perceived stress. You can take down this, right? Total perceived stress is, so within brackets, I'll say the variable name PP stress is of employees, whether the, let's say, average value, the mean value of total perceived stress of employees is significantly different from the value of, let's say, not neutral value, let's say value of 20. Can you test this? Can you check this and tell me? Again, follow the 4 steps. I'm going to give you about, let's say, now it's 8:30. Shall I give you about 5 minutes till 8:35? Can you please let me know? Can you check? Always follow the 4 steps and tell me whether you agree or you do not agree. Right, I'll give you 5 minutes. Two minutes more. Okay, students. 1 minute more. What do you think? There is a significant difference or not? Okay, the time is up. This TP stress significantly different. The average value is significantly different from 20. Mhm. Different or not? Always follow the 4 steps. Anyone?
There's no difference.
Very good, Putha. Thank you very, very much. Right. Okay, so we'll go ahead with the steps. Step number one, very good. So I'm very happy that at least one student was able to tell the answer. The accuracy or not is the accuracy of the answer doesn't matter. Just try. So the first one, step number one, is to establish the null hypothesis. So H naught is there is no significant difference between what? Not the average life satisfaction. Now it's the average total perceived stress of employees and the expected value of 20. Maybe it's a neutral or not, but let's say it's value of 20. Then the decision criteria is if the p value, the probability value or the sig value, the significant value is less than 0.05, reject the null hypothesis. Then what you need to is you have to use data and perform the one sample t-test. Right? Shall we do it? So you would go here. So you would go to data, right? And you'll go to statistics, summaries, tables, those kind of things, that category. Then you will go to classical test of hypothesis and you'll go to t-test. And now it's not perceived stress. So let me have the magnifier so you can see it better. Okay, so you can see it's not T live set now. One sample t-test, that's correct. But again, not T live set, you are going to say PP stress. You are going to go down, 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 then little bit up. And you can see there's TP stress. TP stress, or you can just type it if you want, and you can leave 20 as it is, and you can press OK. And here you get the stress value is 26. The average stress value is 26. And you can see that here, 433 employees have responded. The average stress value is 26. And the sig value is how much? The sig value is, here you can see very clearly, the sig value is 0.0000. Again, quite similar to the earlier case. So the sig value is 0.000. So my question to you is 0.0000 less than 0.05?
Yes.
Is it? Yes, indeed. Right, very good. So in that case, you can go now to the conclusion. So here we'll have similar conclusion. Since this estimated p-value or the sig value is less than 0.05, then null hypothesis that there is no difference between the average value of total perceived stress of employees and the neutral value of 20, not neutral value, the value of 20 is rejected. Thus, these employees, right? Thus, these employees come from a population where the average lifestyle is well above, right? Thus, these employees come from a population where the average total perceived stress is well above the neutral value, the value of 20, right? It's well above the value of 20. 20 was given just a value. It can be the neutral or not. That's a different story. But what we tested was whether it's different from 20. Right? So that is how you'd perform a one sample t-test. Is that clear? Any questions? Quite straightforward, isn't it? Always you are following the 4 steps. Always you are following the 4 steps. Right. So having discussed that as well, now let's navigate to, right, when we have a 4, more than the, actually is the next type of test, where if you have more than 2 groups, right, then how to compare? Now, so far there were 2 things to compare so far. Then we use the t-test, right, as the category of testing, right? T-test, 3 kind of t-test we discussed. Okay, but on the other hand, in this world, we cannot always see only two groups are there. Of course, we can see there are more than two group situations. Therefore, what we can do is we can perform the one-way ANOVA test. We can perform the one-way ANOVA, right? So now let's see what's this one-way ANOVA. This term ANOVA we came across earlier also under regression analysis. ANOVA stands for what? Analysis of variance. ANOVA stands for analysis of variance. Okay. So now let's see how to perform a one-way ANOVA and come into conclusion. But again, since these are kind of a test of differences where you compare more than three groups, again you will be following the 4 steps. Right? 4 steps. So let's see. Yes, you can see ANOVA stands for analysis of variance. ANOVA. And you say one way because you take one characteristic and you see whether that characteristic differs based on the groups. So that's why it says ANOVA allows to hypothesis test 3 plus sample means 3 plus groups. Let's take an example. So in this example, we are going to see the effect of, right, caffeine on productivity. So here, study the effect of caffeine on productivity. Coffee, right? So you're going to see whether coffee has an impact on productivity. So what you do is you have coffee-like beverages. It looks like the same, tastes like the same, and you give employees. But the caffeine levels are different, right? You can see the employees are broken into 3 groups now. They are being classified under 3 groups. The first group is known as 0 milligram group. Then the second group is 10 milligram. Then the third group is 20 milligram group. 3 groups are there. And you can see here, their productivity levels are given. Within 1 hour, these were the amounts they could produce. In the 0 milligram group, within 1 hour, the first employee produced 2 items. The second employee produced 3 items. The third employee produced 1 item. And the fourth employee 4 items. Likewise, then the final employee produced 2 items. Then the people who drank 10 milligram coffee with 10 milligrams of caffeine, they had these productivity levels. Then there was the third group was given double dose, 20 milligram. And you can see this is their productivity levels. Within 1 hour time, these were the things that number of items that they could produce. Right? Okay. So now what we need to see is whether these 3 groups are different from each other. Whether the mean values of these 3 groups are different from each other. And as usual, the null hypothesis that it's not. Right? Okay. So that's what you want. Now here, what's the difference between this scenario and the t-test scenarios? In t-test scenarios, there are only 2 groups. Now you can see here, there are 3 groups. 0 milligram group, 10 milligram group, and 20 milligram group. Right? And we are trying to see whether these 3 groups are different from each other. Right? Clear? First of all, you have to understand the scenario program. And thereafter, you can apply. Okay. So then, to do the testing, you have to follow the 4 steps. Again, same thing. I think you can remember when I was telling these 4 steps at the beginning, I told that you will get indigestion. Because again and again, I'm going to repeat these 4 steps. Again and again and again, I'm going to repeat the 4 steps. Can you remember that? Okay. So step number 1, null hypothesis. Establish null hypothesis, you will say there is no significant difference among the three groups, not between, because now there's more than two groups. So you will say among the three groups regarding their productivity. So there is no significant difference in their mean values, right, of the three groups. Then what you do is you establish the same decision criteria. If the p-value of sigma is less than 0.05, you reject it. Then what you do now is you perform a one-way ANOVA, right? You perform a one-way ANOVA and estimate the p-value. That's what you have to do. Now to perform one-way ANOVA, you cannot go and do that under t-tests. What you have to do is this. You have to go to statistics, linear models and related, and you have to go to ANOVA, and then you have to go to one-way ANOVA and perform the test. Shall we do it together? Right? But before that, you have to download the dataset. So shall we go and download the dataset? You can download it from the elements. So go down to today's week number 7. Here, there's status session 5, caffeine and productivity 5. So it's under week number 7. Can you please download it? So I just downloaded it. And now I'm going to go to Stata and I'm going to open it. So I did not do any manipulations in the earlier dataset, so I can just even keep that and I can just go and say file open. Or you can open a fresh status session, there's no problem. So under downloads, you can see here. Now we have status session 3, caffeine and productivity file. And you can go and press open. Once you open a file, the best practice is what? Check that. Browse. Under browse, so it gives these the productivity levels. Now look at this file. So you can see here, these are the employees, 3 groups. And you can see the productivity levels are given in this column. And the groups are also divided, right? 0 milligram group, right? This is the first set of employees. Then you can see the second set of employees are denoted as 10 milligram group. And third set is given as 20 milligram group. So their numbers are given within right here 1, 2, and 3. So actually these are given value labels. That's why it shows. Is that clear? So you're going to close the data editor window. And now let's perform the one sample t-test once you open it. So you'll go to statistics and go to linear models and related, right? And go to that statistics, linear models and related, and go to ANOVA, and go to one-way ANOVA. Right? Please take down these steps. Right? Statistics, linear models and related, ANOVA, then go to one-way ANOVA. Right? Did you write down? Is it okay? So go to one-way ANOVA. Good. So let me again expand. So you get this dialog box. Now response variable and factor variable. Response variable is what you are trying to test, right? So we'll go to the variable that we are interested in. That's what? Productivity. Productivity is product. number of items produced within 1 hour. Then factor variable is what? Group. Group is the factor variable, right? How you classified these productivity levels. And also there is output produce key summary table. So you can produce that as well, which we like to see that. That's it. Right. And let's press OK. Is it okay? Did you take down? I'll press OK. Here you have. You can see 0 milligram group, the mean value they produced, that there were 5 employees, they produced 2.4 items per hour. Then there were another 5 employees under 10 milligram group, their average productivity level is 1.8, right, per hour. Then the 20 milligram group, it was 4.3. There were 6 employees and their average level was 4.3. Now, are these significantly different? We don't know. In fact, they are different, but are they significantly different? We don't know. So that's why we performed an ANOVA test. That's why we performed an ANOVA test. Right? That's why we performed an ANOVA test. So in the ANOVA test, you can see here the probability is 0.0006. Right? So what I'm going to do is, first of all, let's remove this. Okay. And let's go here. And you're going to record that. And step number 3. 0.0006. The sig value will be here. Now my question to you is, as usual, is 0.0006 is less than 0.05? Yes or no?
Yes.
It's less than 0.05. So in that case, are you going to reject the null hypothesis or not? Indeed, you are going to reject the null hypothesis. Indeed, you are going to reject the null hypothesis. You are going to reject the null hypothesis. Why? Because it's less than 0.05. So you reject that there is no difference, meaning that there is a difference. Isn't it? So that's the conclusion. Since the estimated p-value, sig value is less than 0.05, that's 0.0006 is less than 0.05, the null hypothesis that there is no significant difference, no difference among the groups in terms of their productivity is rejected on an overall basis. Overall, you reject it. I'll tell why you use this term overall a little bit later. Right? If you take on an overall basis, right, you reject, right, that there is no difference. That means there is a difference. Right? There's a difference when you compare these groups. Thus, these employees do not come from the same population in terms of their productivity. So they come from different productivity levels. So caffeine has in fact an impact. So that's why you have significant differences. Right? Is that clear? Now I'm going to give you a small example, an exercise. Right? Question. Use session 3 survey for ED data file and examine whether the total life satisfaction of employees is significantly different among marital categories on an overall basis. Now there are marital status categories now. So I want you to do a test whether the marital categories are different from each other based on total life satisfaction. Now, whether married people are more life satisfied than unmarried people, and whether it's significant, right? So if you go to the, so you have to go to now again to that early download file. You'll go to file and you will go to open. And now you're going to go again to this one, session 3 survey for 85. Open that. And yes, you can, for best practice, you are going to check it. Right, browse. Now you can see marital categories. So let's expand it to see much better. So you can see there are marital categories, several marital categories. Number 4, right? Number 1. Likewise, there are different categories. So if you want, you can go see what are the categories as well. Marital. Marital means whether what you're married or not. Married other than married or not. Huh? Okay. So since browse, I'm not given the chance to edit it. Right? It's not giving me to edit it. Right, never mind. But there are several marital categories, it seems. Isn't it? It's not really- Yeah. Variable 2. So variable 2 has been applied. What's variable 2? If you go here, that's what I was trying to do. Variable 2, you can see, you can expand this. You have 8 marital categories. Single, steady relationship. Likewise, you have 8 marital categories. Single, steady relationship. Likewise, then divorced, widowed. Likewise, several categories. So what we need to see is whether the life satisfaction, average life satisfaction, right, of these groups are significantly different from each other. So that's what we are trying to see. Okay. So you can just close this, the data window, you don't need that. And now we have to see whether there's significant difference. Right. So I'm going to give that to you as a small exercise. Right. And also we shall take also the break, right, for this session, a 20-minute break. And shall we meet at 9:20? Right, we shall meet at 9:20. And meanwhile, right, do a one-way analysis and see whether based on marital categories, whether the total life satisfaction differs. Again, follow the 4 steps, right? Then after that, I'll teach you what's this post-hoc analysis. That later. But first of all, we'll see on an overall basis whether there are significant differences, right, within the marital categories or not. Right? So please take a break and we shall meet at 9:20. Please bring the answer also if possible. Right? Okay. Thank you very much. Okay, students, welcome back. Can you hear me? Students, can you hear me? Students, am I audible?
Yes, sir.
Okay, Buddha, thank you. Thank you very much. I was a bit confused why my good students are not answering. Okay, right. Now, I gave you a task. What was the task? To see whether life satisfaction differs based on what? Based on marital status, right? What's the conclusion? On an overall basis, does it differ? Did someone check that? Do you need more time? You need more time, Buddha? Did you check that? Okay. Right. As I instructed you, Buddha, always follow the 4-step process. Right. So let's establish the 4 steps. Now, this was the question, to see whether total life satisfaction differs based on marital status. Now, again, what you need to do is follow the 4 steps. Okay, step number 1, establish the null hypothesis. What's the null hypothesis? Right? The null hypothesis, you could say, there is no significant difference among. Now it's not big deal because you have more than 2 groups. So you have 8 groups here. There's no significant difference among the 8 groups, 8 marital groups regarding their total life satisfaction. So establish the decision criteria. What's the decision criteria? The decision criteria is again the same. If the probability value or the sig value is less than 0.05, reject the null hypothesis. Then step number 3, using data, perform the one-way ANOVA and estimate the p-value. Okay, shall we do that? So make sure that you have opened the proper survey for ED file. So yes, it's survey for ED file, there's no problem. So now let's run the ANOVA analysis. Statistics, summaries, then classical tests. No. That's for t-test. Now here what? Since you have to do one-way ANOVA, statistics, linear models are related. ANOVA, and one-way ANOVA. Right? You go there. And now it's not productivity. You have to select what? You have to select P-life satisfaction, total life satisfaction, P-life set. Yeah, this one, P-life set. So let me expand. So I selected here T life set. Hope it's clear, T life set. And then you are going to go to factor variable. It's not groups, it's marital. And then you can say produce summary table. And after that, you can press OK. Right? Is that fine? Press OK. And you get a nice output, of course. So you can see in single group, there are 21. Sorry, there are 104 people. Their mean value is 21. Then steady relationship 22, living together 23. There was 36 people, then married first time 23. Likewise, different categories are there. Their life satisfaction levels are different. Right? The average life satisfaction levels are different. And widowed group has the highest life satisfaction. That's curious. Once widowed, they seems very happy. But in fact, there was a right. So now you can see that there are differences, but on an overall basis, whether there's significant difference. To check that, you have to see the ANOVA analysis. Here, yes, the probability value is 0.0000. Now my question to you is, again, we shall now, that's you can record that under step number 3. Step number 3 is to perform one-way ANOVA and record the sig value. Right, is 0.0000. Now my question to you is 0.000 less than 0.05?
Yes.
Yes, very good. So in that case, what's your conclusion? What's your conclusion? You reject the null hypothesis. You reject that there is no difference, meaning that on an overall basis, there are significant differences among these groups. Right? So that's what you say. Among the groups, we have a significant difference. On an overall basis, taken as a whole, there are differences. But however, so that's the conclusion. But however, right, did you compare each group with each? No. Here what you say is, overall basis, there is significant difference. Right? Overall basis, there is significant difference. But you never know what group is different from each other and whether it's significant. Because remember, there are 8 groups. There are 8 groups. So some groups might be different, but some groups might not. Right? Some groups might be different, but some groups might not with each other. So how to know that? So overall significant differences are there, but again, whether, right, now who knows about whether single group and widowed group are significantly different, while maybe I don't know, maybe separated group and yeah, it's very low. In fact, widowed group and divorced group or separated group, whether they are significantly different, or remarried group, whether it's significantly different. We don't know. That's why we need to perform an analysis called post-hoc analysis. So I have given a note here. So the earlier now analysis over, right? So I have come to this analysis, right? This is called individual group differences. If you want to see individual group-wise differences, how to do that? Because what you identified so far is that on an overall basis, whether there are significant differences. But sometimes overall there might be a difference. But when we come to the individual group-wise differences, we don't know. So that's why we have performed here an additional analysis. So I have given a note here. One-way ANOVA analysis indicated whether the difference exist, let's say difference exist among the groups on an overall basis. However, it did not include whether there are differences between the groups on a separate basis. Now, to check whether there are differences, right, between the groups, you need to perform the post-hoc analysis. And the next slide I have got, you can use the option Bonferroni, right, which was there in analysis to see whether there are differences, right? So let's use this option Bonferroni, where it will then perform post-hoc analysis. We'll see what happens. So let's go again to this analysis, where we'll go to again statistics, linear models and related, ANOVA and MANOVA, and one-way ANOVA. Then you can see that there is an option here, Bonferroni, multiple comparison tests. So then it compares each group with other, right? So you can go to Bonferroni. There are other tests as well. Bonferroni is quite popular. Bonferroni. And you press OK. Now see what has it here. Now it compares with each group. So let me expand it and run it so it will show much better result. So let me further expand it and run it. Hopefully it will give in one screen. Yeah, much better. Okay. Now see what's there. So what it has done is now it takes each pair steady relationship with single and it gives the sig value, right? Sig value. So it has to be less than 0.05 to say that there's a significant difference. Is there a significant difference between steady relationship and single? No, because the sig value is in fact 1. Here also marginally it's above 0.05. So there's no significant difference. Here there's significant difference. You can see between divorced and remarried. Divorced and remarried, of course, separate, right? Separate and remarried, there's significant difference. You can see, although, right, you could see that on an overall basis, it said that there are differences. Now you can see only some of the groups have specific differences. Now, separate and remarried, there's a significant difference. Divorced and remarried, there's a significant difference. Right? But other than that, oh yeah, then this one. What's that? Widowed and separate. They have significant difference. So likewise, it's giving these analysis. So actually, widowed one has 11. Yeah, you can see the difference is quite significant. Right, 11. So widowed group is higher. If there's minus, that means divorce group is low than the other group that's compared. So you can see some groups are only different from each other on a significant basis. So particularly remarried, separate, and with separate, divorced, those groups are quite significantly different from each other. So you can see this in this comparison, multiple comparisons, it gives a kind of each group is compared with each other. So better understanding is given. But in one way, typical only if you perform one-way analysis, it told whether on an overall basis, whether there was a difference or not. But you can see only some groups have differences with each other, although in the overall result, it gave that overall basis, there are differences. Indeed, we see there's a difference, but again, by looking at this, we get only the right Bonferroni's test, we could see what groups are different from each other. Okay? Bonferroni again, we say what groups are different from each other. We can see an output over here. Compression and productivity level. Now, of course, we can apply this to the productivity level example as well. Right. So why not you apply this to productivity example? So you download the dataset on the coffee and productivity. So there were three groups, 0 milligram and 10 milligram and 20 milligram groups. What groups are different from each other? ANOVA indicated that groups are different. But what groups are different from each other, we don't know exact differences. Right? Can you perform a Bonferroni analysis? Bonferroni analysis at one pull and tell me the analysis there. But again, can you run the Bonferroni analysis and tell? So for this, again, choose the proper data file. So I'm going to again go to Stata and go and file, open. I'll open the earlier file, coffee and productivity. Coffee and productivity is the file. Session 5, coffee and productivity, open it. Right, it's now open. Now perform a one-way ANOVA with Bonferroni analysis to see what groups are different from each other. Exactly. How can you do that? You will go to statistics, linear modes and related, ANOVA, then one-way ANOVA. Then it's not life satisfaction. You're going to see the productivity. And factor is basically what the groups. And Bonferroni, you tick that and also produce some statistics. And you're going to press OK. You get quite similar results on the top. 0 milligram, 2.4. Let me expand it. 0 milligram is 2.4, 1.8, 4.3. And on an overall basis, you saw there are significant differences. Right, overall basis, because the probability value is less than 0.05. So you reject the null hypothesis that there's no difference. So in fact, you conclude that there is a difference. But what groups are different from each other, you don't know exact differences. So then you go down and you can see here Bonferroni analysis given. You can see it has compared all group comparisons. 0 and 10 milligram group has been compared. Is there a difference between 0 and 10 milligram? So this is the difference. So the 10 milligram group on average is less, minus 0.6 with 0 milligram group. You can see that very well here. Right, if you go and see, yes, 10 milligram group is 1.8, 0 milligram group is 2.4. That means 0.6, right? It's lower, 10 milligram. That's why it's negative here. And it's a difference significant? No. So the significant level is 0.849. So there's no significant difference. But on the other hand, you can see 20 milligram group and 0 milligram group, there is 1.9 difference. 20 milligram group on average has 1.9, right, higher than 0 milligram group. And the difference is in fact significant. You can see it's it's below 0.05. So therefore, the productivity levels between 0 and 20 are significant. If you go here, 0 is 2.4 and 20 is 4.3. So the difference is this one, 1.93. It's significantly different. Then 20 and 10. Again, the productivity level is, there's huge difference, 2.5. So 20 milligram group is higher than the 10 milligram group. And the difference is 0.001, which is well below 0.05. So there's significant difference again. So seems high dose of caffeine had increased the productivity. Right? A lower dose of 10 milligram has in fact reduced the productivity. But high dose has increased the productivity. So that's the answer. Right? Now do a test for stress on book, right, and see whether based on marital status, whether the stress level differs overall basis as well as on a, let's say, group basis, individual basis. You take the marital groups and compare with each other and see whether there's significant difference. Use stress variable in the survey for AD5. Can you check that and tell me? So for that, please use the survey for AD5. So I'm going to give you 5 minutes. Please take 5 minutes. First, open the survey for AD5. So I'm going to go to Stata. I'm going to go to File, Open, and go to a download folder. And please open survey for AD5. And now see whether the stress level differs based on marital status level on an overall basis as well as on a individual basis. Can you check that? Stress levels. I'll give you 5 minutes. Can you check that? Whether based on marital status, the overall difference which we checked earlier, and whether there are individual differences. Now based on stress levels. Is there a difference? First, Putha, make sure that you have open status in 3 survey for ED5. Right? And what I want to know is whether based on marital status, whether the stress levels differ on an overall basis as well as on an individual basis. Okay, we'll check that. Let's do it. So anyone got the answer? Let's see. You can go to statistics, linear modes and related, ANOVA, one way ANOVA. Now you are going to choose stress. Right, you are going to go to this list. Hold it up. You can see TP stress is there. And it's not groups. You are going to say the marital status. Bond Ferranis has been selected and produce summary tables has been selected. And I got press OK. Here, again, the stress level is based on marital status is given. Who is having the highest stress? 31. Separated people are having the highest stress. The next highest, there are two steady relationship as well as divorced people are having that. Who is having the lowest stress? Surprise, surprise. Widowed guys are having the lowest stress. Right. Then we can go to one minor table and see on an overall basis, right? Since the SIC value is less than 0.05, on an overall basis, there are differences. Overall basis, there's a difference among the groups. But how about individual group comparisons? Here you can see all the comparisons are done. Right? Single and steady relationship, there's no difference. Here you don't see differences. No groups are different from each other. Because all SIG values, which is listed below the numbers, this is the difference and this is whether it's significant or not. Yes, it says no group is different from each other. Right, on an individual basis. Overall, although the overall basis it says there's a difference, taking on an individual basis, we cannot see any difference. It was all above 0.05. You can see, right? Overall basis, it says there's a difference, but taken individually, it's not different. So that's how, Buddha, you are going to perform a one-way analysis with post-hoc analysis. Post-hoc analysis is where you are trying to see, right, the individual differences. Okay. Is that clear? Students, is it clear? It seems it's clear. Right. So let me give you another exercise too. Right. Okay. Let's see. Let's try to give a small exercise for you. Another one, so you can. Now you can see here, they have created 3 age groups. Right, let's see what others. So 3 age groups have been created. Let's go to the edit command and check that. What are 3 age groups? If you go here, so it's, you go down, down, down. It's age 5 and age 3. You can see age 5, 3 age groups, and 5 age groups. So what else? So value label 5 and 6, 6 and 7 has been applied. So what's that? We'll see what others. So age group, let's see, 3, and then age group 5. Let's take age group 3. So if you go here, value label is there. And let's see, age group 3, number 6. So here they have broken the employees into 3 groups. Age group 3, 18 to 29, 30 to 44, and 45 plus. Right? Is that clear? So these are the 3 ages. All the employees have been classified under these 3 groups. Okay. Age group 3 is there. So that's the categorical variable, which classifies, groups these employees into 3 categories, 3 groups. Now my question is, check whether life satisfaction differs based on these age groups. You have 3 age groups, whether the total life satisfaction differs based on these 3 age groups on an overall basis as well as on an individual basis. Can you check that? I'm going to give you 5 minutes. So always follow those 4 steps, right? Based on the age groups, check whether there's significant difference. I can check that and let me know. Based on age groups, whether the total life satisfaction differs. On an overall basis as well as individual basis. Take your time. Okay, 2 minutes more. Okay, let's see. So how to perform that? So again, establish the 4 steps. Step number 1. What's step number 1? Null hypothesis. Establish a null hypothesis H naught. There is no significant difference, right, among the 3 age groups in terms of their life satisfaction, right? There is no difference among the 3 age groups on their total life satisfaction. Okay, so no, that's what we say null hypothesis. Then step number 2, establish the decision criteria. What's the decision criteria? If the sig value or the p value is less than 0.05, reject the null hypothesis. That was the decision criteria. Then step number 3. What was step number 3, Buddha? Using data, perform one-way analysis and also in post-hoc analysis. So how could you do that? You go to statistics, linear modes and related ANOVA, and you go to one-way. And it's not stress. Let's use total life satisfaction. So I'm going to explain this. I'm going to use total life satisfaction. Go to the bottom, go a little bit up, and you can have T life set. And bone Ferrani is already selected, then product summary table, produce summary table, then not marital status, we'll be selecting 3 age groups. Age group 3. And press OK. You get these things. Okay, you can see here. These the 3 age groups, 18 to 29. They are right. Total life satisfaction is 23. Then comes 30 to 44. It's quite low, 22. And then again 45 plus becomes 23. What does the ANOVA analysis indicate? Now you can see the sig value is well above 0.05. So can you reject the null hypothesis? No, you can't. So therefore, the conclusion is what? So you write down under step number 3, it's the sig value is 0.2223. And then under conclusion, you would say what? There is no significant difference between, or in fact, among, right, these 3 age groups on an overall basis. On an overall basis. And then you can go and see the individual comparisons. Also, the individual comparison indicate that the sig values in all cases are well above 0.05. So, right, you would also claim accordingly, right, when you take individually the groups, there is no difference as well. Right, individually gatta groups athara difference yakne. Is that clear? Clear? Students, are you sleeping or okay? Good at least. Right. Okay, now let's go back to our slideshow. So I'm going to teach you another thing. Right now we use the for the post-hoc analysis what? Bone-Ferrani's test. But however, there is another test called Tukey's post-hoc analysis. Now, Bone-Ferrani and Tukey are comparative post-hoc analysis. Right? And what's the difference? Yeah, I given a small note at the end. Right. What we should use, Bonferroni or Tukey. For typical one-way ANOVA with 3 plus groups, where you want to know which specific groups differ, Tukey is generally preferred and more powerful option. So therefore, sometimes when you have 3 plus groups, right? Not that time, not 20 or 30 groups, but just 3 plus groups, like not that much. In that case, you might perform the Tukey's test. But the problem is there is no menu command to perform a Tukey's analysis. So that's why I have given here. How can you perform a Tukey's analysis? Right? Tukey's analysis. Now to do this Tukey's analysis, earlier we performed the Bonferroni analysis. Now we shall perform a Tukey's analysis. Almost it will give the same result. So how to perform a Tukey's analysis? So for that we'll use the coffee dataset, right? The coffee and productivity dataset. I'm going to go to that. So I'm going to go back. Open. You downloaded it earlier. Coffee and productivity dataset. You can see it. Coffee and productivity dataset. Session 3. Session 5. Coffee and productivity dataset. Please open that. Right. So you open that. Right. And now earlier what we did was, of course, check the file, browse, you browse, we are out of it. See, here it opened, there's no problem. So these are the 3 groups and the productivity levels are given with the copy and productivity file. Then now I ask you to, if I ask you to perform and test whether overall basis as well as individual basis, whether there are differences, you could perform what I told you earlier. Follow the 4 steps, which we did already. So it's here. So it's documented already as well. Okay. So step number 1, establish a null hypothesis. There's no significant difference among the 3 groups regarding their productivity. Then establish the addition criteria. So if less than 0.05, reject the null hypothesis. And then using Stata, perform a one-way ANOVA analysis, which we did earlier. Right? So if I show you again how to do that. So make sure that you have opened the caffeine and productivity file. You go to statistics, and then you go to linear models and data, ANOVA, and one-way ANOVA. And here it's not life satisfaction. We are using what? Productivity. And the factor variable is the groups, which we did earlier. Again, I'm repeat telecasting. But now I select Bonferroni as well as product summary tables. Right. So it gives the earlier result. Right. You can see here the product results are different. And the one-way ANOVA indicates that the F value, the probability of the test is less than 0.05. So that shows on an overall basis there is a significant difference, right, among the groups. But what groups are different from each other? You did a Bonferroni's post-hoc analysis, and you identified that 0 milligram and 20 milligram group as well as 10 milligram and 20 milligram group are significantly different. But you understood that 0 milligram and 10 milligram groups are not significantly different because the sig value is listed here. It's 0.849, which is not significant. Right? So we understood that. But what I suggest is to perform a two-case analysis as well. Because what's told is that two-key might give more accurate results. So how to perform a two-case analysis? It's very simple. What you do is you go back here to perform a two-piece analysis, you go back and you go here. You copy these two lines. Two key. Product is the productivity. So I'm going to copy these two lines and I'm going to run that instead to run the two keys analysis. Because for some unknown reason, right, in the menu, it's only Bonferroni they have here. But on the other hand, two keys analysis is much more popular. So I copied and pasted, and while they are there in the command window, I hit enter. So now it gives the two keys analysis. It gives multiple tables. So even regression is given. I'm not interested in that. I'm interested in this table. Now see what this table gives. The last table. It compares each group. Can you see that? 10 to 0. And it gives a t-value for two keys analysis. It's 0.519. There's no significant difference between 0 and 10. But how about 20 and 0? Yes, there's significant difference. How about 20 and 10? Yes, there's significant difference. You can see almost these values are comparable with what? Bonferroni's post-hoc analysis, which we had discussed earlier. So if you go to Bonferroni, you can see, right? So this was the Bonferroni's analysis. Bonferroni, you can see. So it also gave quite similar results, but here the sig value has dropped. It was 0.5 something. It's almost the same. So therefore, these are comparative tests. Right? Comparative test. And what's preferred is the two case analysis. Okay. Is that clear? Okay. Now, let me ask you to run a two keys analysis for marital status. Go to the next dataset, survey for ED dataset, and use marital status now and perform a two keys analysis to see whether based on marital status, whether the total life satisfaction differs. Can you check that, please? Marital status. Perform a two keys analysis. Earlier, we performed a Bonferroni analysis. Now, I'm going to give you a few time, right, few minutes to perform a two keys analysis for Bonferroni, for marital status, right? Two keys analysis, post-hoc analysis for marital status and total life satisfaction. I'm going to give you about maybe again 5 minutes. Can you please do that? So first of all, right, let me help you. First of all, open the correct data file. So it's a 4ED survey 4ED file. So I'm going to open it from here. Or you can go to file and open up whatever that's good for you. File open. So you can see here session 3 survey 4ED file is there. Open that please. And now let's run a normal one-way ANOVA. Statistics, linear, models and related one-way ANOVA, the analysis of variance. So it's not product, you go for total life satisfaction. Okay, T life set is there. Total life satisfaction. Then you have not groups. Let's use marital. And Bonferroni is selected, but now we don't need to run Bonferroni because let's say we want to run Tukey Bonferroni and produce the summary table. I'm just going to say it's okay. So these are the same result we got earlier. So on an overall basis, there's a significant difference. That's what it shows you. Right. But then the Bonferroni analysis is given. So it indicates that in certain instances over here, there are significant differences, but on here, there's no. But what I wanted you to run is the Tukey's post-hoc analysis. So how can you run the Tukey's post-hoc analysis? Go here, copy again these two lines and paste it over. Now it's not product, it's T life set, total life satisfaction. T life, total life satisfaction. Because total life satisfaction is the variable that we are interested in. So I have taken total life set, T life set. T life set and group. No, there's no variable for group. It's marital. Okay. So make changes. And again, here there's nothing called group. Here marital. So you have to make changes because what I have given there is for fee and productivity exam. So I change that marital. So now hit enter. Here it gives a huge comparison. Now let's see whether there are differences. Yeah. Steady relationship versus single, no difference. No, here there's a difference. Married first time and single, there's significant difference. So married first time seems quite happy than single people. Indeed, right? If you marry with a person that you really love, of course, then you'll be more happier, more satisfied than being single. But then other than that, I don't see anything less than 0.05. Marginally, this has one, but again, it's here. This one is significantly different. You can see separated, and if you compare married first time, there's significant difference. And separated people are significantly lower satisfied than married first time because it's -1. And here, this also we can see. We can see this also again divorced versus remarried. Divorced people are quite unhappy than remarried. And you can see the level of significance is very less than 0.05. And here also widowed and separated. Widowed people are quite satisfied than separated people. Right? Here there's significant difference because it's 0.01, which is less than 0.05. So this is Tukey's analysis. We did a Bonferroni analysis for this as well. This is how you would perform a Tukey's analysis. So sometimes the researchers will have to be, you are asked to perform a Tukey's analysis. So this is how you would perform a Tukey's analysis for multiple conventions. Okay. So I recommend you to watch this video. Now this is recorded and it's made available to you. Right. Watch this and perform today's analysis again if you have not done so. So today I taught you 3 things. Right? I taught you the remaining t-test. What was the remaining t-test I taught you? One sample t-test. Then I came into comparison of more than 2 groups. I told you that you can compare more than two groups, of course, 3+ groups by using one-way ANOVA. So I told you that as well. But however, one-way ANOVA provides overall basis whether there is a difference or not. But on a single basis, individually, if you take the groups, they might not be different, or they might be different. Right? Now to check that, I told you how to perform post-hoc analysis. And I told you that there are two kinds of post-hoc analysis. One is called Bonferroni, the other one is Tukey. Right? First, I demonstrated how to perform a Bonferroni analysis and perform a post-hoc analysis to see whether individual groups are different from each other. Right? Then I told you much more preferred method is Tukey's post-hoc analysis. Then I showed you how to perform a Tukey's post-hoc analysis. Okay. So that's what we did today. So I see only few number of students, so I highly recommend you to watch this video for people who are not here, and also for people who are here. Why not you watch this again and revise what we discussed? Because for the examination purpose, it's going to be really important. Right. Okay, so with that, then we'll complete for today. Do you have any questions? You can ask me.
So can you share the QR code?
Ah, my God. Of course. Okay. No question. So yeah, let me share the QR code. Thank you, Buddha, for reminding. Really appreciated. Huh? Taking local copy of 22 without attendance. So please be ready for the attendance. So this is your batch, right? 16A MOH WWD. Of course, right? Right. So let's go to the attendance. And I don't know other attendance material, so I'm going to create add session. And today is 3rd July. And let's set it from 1930. That's 7:30. 7:30 till 22:30. It's very good you told me. If not, I would have 10 multiple sessions. Right. That's fine. Then allow students self. Protect QR code. Okay, let's add it. Show more. Add. Okay, 3rd July. So please be ready and tell me whether it works, right? If not, I will just check again. Okay. Can you please check? Is it working, Buddha?
Yes, sir, it's right.
Excellent. Thank you very much, Buddha. Thank you very much for reminding. Okay, students, shall I close the window? Everyone took attendance? Okay. Is it fine? Right. So we have recorded the attendance. We have 17 people who are recorded attendance. Okay, with us. So thank you very much. And let me wish you a good night. Please take care. And we'll meet this Sunday.
Thank you, sir.
Thank you, sir. Good night.
Good night, Putta. Thank you. Thank you, Putta. Thank you very much and good night. Good night,
Thank you,
Putta. Please
sir.
take care. Good
Thank you,
night.
sir.
Good night. Thank you, Putta. Good night.
Thank you,